Hello everyone. Let's start today's session with the last program of network simulator. The aim of the program is to implement the link state routing algorithm. Okay. So the one program from part A, what we are studying is implementation of the routing algorithm. We have n number of routing algorithms in computer networks. But here we are discussing a simplest and easiest routing method that is known as link state. Okay, the link state protocol is performed by every switching node in the network. That is, the node that are prepared to forward the packets in the internet, they are called as a router. We know that, like from sender to a destination. In between that we may have n number of routers, generally we call it as hop. Okay, so how the packets will transmitted, whether I need to find generally all the paths and how I can send the data, how to get the shortest path, and by depending upon its weight concept. So all this depends, but in order to find the shortest path between the source and the sender, the simplest method is a link state routing algorithm. The basic concept of link state routing is that every node in the network constructs a map of connectivity to the network in the form of a graph, which shows that the nodes are connected to which other node, and each node then independently calculates the next logical path from it to every possible destinations in the network. That means each collection of the best path will then form a table. That table is known as routing table. Okay, the link state algorithms is very simplest routing algorithm. It just calculates every time what is the shortest distance in terms of the weight given on the duplex link. Here we will select one simple example. I will explain the route network, then we will go with respect to the program. You can see here I have selected a 5 node network N0, N1, N2, N3 and N4. So they are connected as shown in figure. N0 to N1, one duplex link, N0 to N2, N0 to N3. So N0 can connect 3 different nodes with 3 different duplex link. Similarly, N1 can also connected with 3 duplex link and N2 is also with 3 duplex link, but N4 is with only 2 and N3 is only with N0. And some of the values are represented on this duplex link, that is nothing but cost of the duplex link, or I can say weight. Either you can represent it in terms of kilometer, meter, some weight has been given. Accordingly, the sender node will select which path is the best for the transmitting the packets. So for this network, let's assume the node N0 is my transmitter node and node N4 is the receiver. Now I want to send a packet from N0 to N4. By using link state algorithm, it will first evaluate all the weight from N0 whichever node is connected. So N0 to N3 5 is a weight, N0 to N2 14 is the weight, N0 to N4 the weight is 8. So when you see this, which is connected indirectly to N4 by a hop N2, I have only 2 connections. N3 no more concern, so generally I can skip this. So N4 14 and with this link 8. So by comparing the value of the weight, the lesser value path is N0 to N1. Hence the algorithm will select from N0 to N1. So from N1 it will again cross verify or it will check for the next hop. So from N1 I can directly go to destination, that is one path, or I can go from N1 to N2 or N2 to N4. But every time it has to calculate its shortest path or a weight the weight should be lesser than all other weights. So that particular routing should be considered for transmission. So already at N1 I have my total weight is 8. From N1 to N4, N4 is my receiver now. N1 to N4, previous 8 plus 3. So that is equal to 11. Okay. By a weight of 11 I can reach to N4. Let's assume some of the other route also I have. Let's calculate the shortest path. So when I see this particular path, from N1 to N2, the weight is 4. Previous weight was 8. 8 plus 4, 12. Again from N2 to N4, another 4 I have. So from N2 to N4, it will take another 4. So the total weight becomes 12 plus 4, 16. So with the route N0 to N1, N1 to N4, the total weight is 11. And with the direction N0 to N1, N1 to N2 and N2 to N4, I have got 16 weight. Hence, the smallest weight is with this. Hence, the packet will be transmitted from N0 to N1 and N1 to N4. Okay. You can do one more changes. You can just change the weight of N1 to N2 and N2 to N4, and you can see whether it will become a shortest path or not and how the packet transmitted can takes place. Okay, just replace this 4 by 1 and this 4 is also by 1. So from here 8 and from 3 11. But when you see this 8, if you assume this is 1, 8 plus 1 9. From 9 again if you assume this is 1, 9 plus 1 10. So the total weight becomes, the total cost of this particular path becomes 10. So 10 is lesser than 11. Hence my data should select the path from N0 to N1, N1 to N2 and then N2 to N4. So like that, here we have to select what is the shortest path from source to destination depending upon the cost weight of the duplex link. Now how to implement the TCL script for this program? So the simple concept, everything is same. Declare file node, declare the duplex link between those, give the parameter of bandwidth and the propagation delay and all, and I will be selecting only UDP protocol transmissions for this network because I don't want whether acknowledgement will be received or not. Just my intention is to send the packet. So N0 becomes my source. This source will be UDP source. Similarly, N4 is my receiver. The receiver becomes null. And here one extra thing is I have to introduce the cost, a weight between each duplex link. N0 with respect to N3, N2, N1. So N1 with respect to N0, N2, N4. Like that I have to introduce one more syntax, one more set of statement where the cost of the matrix can be implemented. Okay. I hope the fundamental basic concept is clear. So let's start the program. Okay. This is the implementation of link state routing algorithm. As I said, the concept is remain same. Simulation instantiation, creating trace file and the NAM file. 5 nodes I have, so I will be declaring 5 different nodes, N0, N1, N2, N3 and N4. So after the node is declared, I have to create a duplex link between all the nodes. Okay. So according to the network, in what way the network should be designed, accordingly you can create the duplex link and represents its key limit between each node pair, and let's assume this particular key limit is constant, and also the bandwidth and the propagation delay is also kept constant. Okay. Then I have to say how the network is oriented. You know by this time how to give the orientation for the network from reference node. Okay. So till this everything is same. So as I said, cost of the each duplex link should be given. Then the link cost between the node is given through this particular statement. So my object, my NS cost between the duplex link N0 and N1, the weight is 8. Similarly, N0 to N2, the weight is 14. N0 to N3, the weight is 5. Similarly, in the similar way, you just declare the cost between the link N1 to N2, N1 to N4. Similarly, for another link N2 to N4. Okay. So only this is an additional part for this program. So once this is declared, next I have to initiate my traffic agent and then application protocol. Okay, means transport layer and application layer should be initialized by declaring its respective agents. So I will be writing the set of protocols for application layer and also for agent definition. Okay, so N0 is my sender, that is source, and N4 becomes the receiver. Okay, so the total amount of packet size is considered as 1500. Okay, so after this I have to give some event when I should start my packet transmission and when I have to stop my particular simulation. So the start CBR packet transmission at 1 millisecond and stop at 10 millisecond is just I will increase this value to something 25. Okay, 25 milliseconds. So here I have, see carefully listen here, some method what I said in order to find the shortest path. In this NS2 we have an inbuilt function. We have an inbuilt function which can be invoked in order to find the shortest path between the source and the receiver. So for link state, we have n number of routing algorithm, link state routing algorithm, Dijkstra routing algorithm, distance vector routing algorithm, many are there. But here link state is used because of its simplicity. So in order to calculate directly the shortest path, I can just invoke the inbuilt function that is known as RT-PRO, routing protocol for link state. Okay, so here I will be executing only NAM file because I just want to see how the packet is transmitted. Again, if you want to calculate what is the draw packet, what is the amount of packet received by the receiver, everything will be remain same. You just write one more AWK script and call here, that will be fine. Okay, so this is a NAM file accessing executing command, then flush through a procedure prop finish. Okay, then you just say run my program. So as I have changed here the stop time is 25, so I will be changing the NAM and wireless is also with respect to, I will change the timings 25 and here also I will do the changes with respect to 25 so that you can be clearly how the packet is transmitted from which node to which node. Okay, just save the program. So we'll see how this is executed. Okay, as you have seen the network here, according to this network, now you are clear that my packet should transmit from N0 to N1 and N1 to N4. Clear? So we'll execute that. Okay, what is the command for execution? So let me clear everything first. Command for execution is ns space file name is n61.tcl, then enter. So once you enter, your NAM file will be generated like this. So let me check. So execute this, just run. So you can see the V. After 1 it becomes 1.0. At 1.0 time slot, the packet will start sending. So still it is 2. Let me change the step size. Yeah, see, you can see what is the path. The path selected is from N0 to N1, N1 to N4. So this will end at 25th millisecond. Now the simulation is completed. So now if you want to see here also how that execution taken place, what is the path has been considered for the transmission. So we have one more command for that. So let me go back to my program. So gedit space n61.tcl, just I will put ampersand in order to view parallelly. So here I have one particular link, or you can say execution command in order to view from way to way. This is a trace file format. From the trace file format 479, some particular line, see here, this is some particular line of my trace file. Just I have taken that in order to invoke from where to where the packets are transmitted. Just have copied that and I will paste it here and I will enter. Okay, so you can see the syntax of trace file. The packets are transmitted only from 0 to 1, 1 to 4, again 0 to 1, 1 to 4, 0 to 1, 1 to 4. Okay, so this is a program executions, or you can see how the packets or shortest routing path can be selected within the given network design. I hope the concept is clear for everyone. Keep learning. Wish you all the best for everyone. Thank you.